All right. This is CISS226, Introduction to Java, and I am Mike Zellers. I'll be teaching the course this semester. And what I want to do today is talk a little bit about the way the course is set up, and then get into some actual Java code, some simple Java code, and to give you the background of what you need to do your thing in this class. Okay. First of all, some of you may have noticed that you signed up for maybe an online section and you got put in a blended section. That's because in reality, the blended and the online are actually the same class. All right, they're both this class. Let me tell you how that works if I'm not confusing you already. You have three options for watching the lectures in this class. Everyone in the class, regardless of what course they've signed up for. You can watch the lectures in person. All right. You can, so every Monday at 1 p.m., I'm in BU 103. And you can come and watch the lectures in person. Second thing that you could do is you can watch them synchronously online. By that, I mean that you can watch them as they occur simultaneously online via WebEx. And there's a link to my WebEx room on campus. You just link to virtual classroom right here. Click on that, you get to it. It's also listed on the syllabus. And the third option, so watch in person, watch synchronously online. The third is to watch asynchronously online. It means to watch it at your convenience. So you can, the videos are posted to YouTube, and you are welcome to watch them at your convenience anytime. I don't care which one you pick. Pick the one that works best for you and your life. The whole idea of having this flexibility is I know people, especially people at community college, they have responsibilities other than school, you know. What I try to do in these courses is to accommodate everyone's situation the best that I can. And this is the best that I came up with as far as accommodating that. So you can watch it in person if you're one of those people that think they work better in person. You're welcome to come and attend. And you know, the advantage of that is you can ask questions. You know, it's a little more personal when you're in person. Some people find the online environment to be kind of cold. All right, but this is more human if you do it in person, more personal, I would say. And you can ask questions as they occur during the class. All right. If you watch them synchronously online, in other words, you log on to WebEx Monday at 1 p.m., you don't get that personal touch because you'll be watching me on a screen, but you will be able to answer questions during the class. All right. You can send me a chat message, or I think there's an icon to raise your hand, or whatever you need to do to get my attention. And I will answer your questions. So that's the advantage of that. And you don't have to be in the room with me. So for example, if you're not feeling well, you can stay at home and watch the class online. Still get the benefit of being able to ask questions live, and I will answer them live just as I'm delivering the lecture. The third option is just to watch it later on YouTube. Now you can still ask questions then too, but the questions will be in the form of an email to me. So it's a little bit of lag in getting my response to your questions. You know, it's not immediate like if you're in person or online synchronously, but it has the advantage of being able to watch it wherever you want. You know, you can watch it at any time. So if you work certain hours, you can watch it, when you're off, or if you have other responsibilities or appointments or whatever. Now, you don't have to tell me which option you choose, and you can change the option every week. All right. And they all have their advantages and disadvantages. You know what you prefer, and you know what your life is at and what other responsibilities you have. So I trust you to take the best option for you on a week-by-week basis. Let's see. I thought there was something I was going to say, but I don't remember it. Oh, well. I'm going to go over some of the material for this course. And I'm going to go over the syllabus. I'm not going to read the syllabus to you because that's kind of a waste. You can read. I trust you to read the syllabus and the other materials that are indicated online. Let me have a word about labs before we go on to the syllabus. This class has a lab component as well. Now, you're welcome to come to lab. I will be in BU 210 at 2 to 3 p.m. on Mondays. So BU 210, 2 to 3 p.m. on Mondays. I will be there in person. And again, if you want that personal attention of being physically in the same room as me, you're welcome to come to lab then. You're also welcome to come via WebEx again. There'll be a brief minute where I log off to go from the lecture room to the lab room. But other than that, I'll be right back on by 2 p.m. and you can ask me the questions. That's really a nice option because you can actually share your screen with me and I can see exactly what you're doing. And I can answer your questions that way too. You also can email me questions. And when you email me questions, I ask a few things. First of all, you send me all your code. All right, don't send me a screenshot of your code. Don't send me one of the files. Don't copy and paste your code and put it in an email message. Take the folder that all your code is in for that particular assignment, zip it up and send me the zip file. The same thing that you're going to do when you turn it in. So zip up the folder that contains your assignment, email it to, and be specific about what is wrong. Don't make me have to hunt through it. If a calculation doesn't work correct, for example, tell me, hey, this program doesn't calculate students that take more than 18 credit hours. It doesn't calculate their tuition correctly. Or maybe in-county students that work more than that take more than 18 credit hours, it isn't calculating correctly. So be precise, all right, with that. I'll do my best I can, the best I can to answer via email. You are also welcome to request a time to meet with me outside of my standard lab/office hours. And when you do that, just give me some options as far as what days and times you're available. I can usually accommodate most everyone's schedule. So just tell me that, on Tuesdays you're available, from noon to 4, and on Wednesdays you're available from 9 to 12. Something like that. Give me a few options to pick from, and chances are good I'll be able to accommodate your request as far as that goes. Now, our lab is Monday from 2 to 3 p.m. However, you are welcome to come to the other courses I teach lab. My labs typically are not full, and therefore I open up my labs so that you can come anytime during my lab times when I'm in lab, regardless of what class it's formally scheduled as being part of. So for example, Mondays from 10 to 11 and 2 to 3, I'm available. 10 to 11, I'm in BU 102, 2 to 3, I'm in BU 210. Tuesdays, I am available from 10 to 11 in BU 210 and 2 to 3 in BU 210. You can also access it via WebEx if you're not physically on campus. So it gives you plenty of opportunity to come and connect with me if you're having trouble with something. Either in person or via WebEx. I'm usually in there right at 2 or 10 or 2, depending on which session we're talking about. But if I'm not there immediately at the hour, give me a few minutes. Sometimes I have to stop and use a restroom or whatever. So I'll be in there shortly after. So all the syllabus is important, but really pay attention to this part. Pay very close attention to this part, because that's really critical in your success in this class. Some of the other stuff I'll let you read on your own. Some college policies, my approach. I have a policy on late work, and it's a little different than maybe other instructors you've had. I am interested more in getting quality work from you. So I don't want you rushing to turn something in that is halfway done just so that you can say, I got it in on time. All right. If you're struggling with something, if you're having a hard time with it, just let me know. Hey, I'm a little behind on lab 3. I think I know what I'm doing. I just haven't had the opportunity because I've worked extra hours or whatever. You don't even really need to go into detail about personal reasons that you have for not being able to get the work done on time, but just let me know. Give me a warning that there's a heads up. Or if you do have a problem with the assignment, like, yeah, I'm almost done with the assignment, but I can't quite figure out how to do A, B, or C. All right. And then we can talk about it. I can try to answer via email, or we can schedule a time or whatever. If either of those two things are the case, I don't mind accepting late work and giving you full credit for it. What I don't like is when someone simply doesn't show up for class, is not in contact with me, doesn't show up either online or in person, or doesn't watch the lecture videos, and then all of a sudden shows up at week 6 and tries to turn in the first week assignment without giving me any good reason why they would be late 5 weeks. All right. So stay in contact with me if you're going to be late is sort of the key lesson from this section. And again, don't divulge any personal information you don't want to divulge. Now, the one thing I will say is I think this is a good feature that can help students, but don't use it as a crutch. So if you're noticing that every single lab assignment, you're just not being able to get in on time, then that might be a sign that we need to do something. Maybe you're not understanding something correctly. Maybe I need to go over something with you. Maybe you need to devote more time to the course. All right. But we can talk about it if that's the case, if you're habitually behind in your lab assignments. If I could emphasize one thing, don't hesitate to ask questions, whether it be in class or whether it be online. Don't hesitate to ask. If you ask a question, I might not always give you a direct answer. I may point you in the right direction to figure out the answer, but I don't think I've ever gotten a question that I've just said, hey, I'm not going to answer that at all. It's a bad question. All right. Maybe I have, but I don't remember that ever happening. All right. I do have a policy about AI. And I thought very carefully about this because using AI is a valuable skill. And I think programmers that use AI well have an advantage over programmers that don't know the tools and don't understand AI. I use AI myself in figuring things out if I'm working in a technology that maybe I'm not as familiar with and I'm trying to do things. I do a lot of stuff in Logic Pro, an audio processing program on the Mac. And that has so many features, and I've only scratched the surface of the features. So if I need how to do something, I'll ask it how to do something. But that's how you should be using AI in this class. You should be using it as a learning tool. You know, if you are not sure what an if statement looks like, for example, you could ask AI, you know, what does an if statement in Java look like? That's just an example for that. You are not permitted to let AI do your complete assignment. All right. If I suspect that AI completed your assignment, we'll have a discussion about it and we'll figure out what's going on and we'll figure out where to go from there. So I have listings of prohibited use, permitted use, documentation. Oh, that's one thing. I do want you to, if you use AI, I want you to create a document and say, I used AI to help me figure out how to index an array, for example. There's some more stuff in here. Read on your own. We don't have a textbook in this class, do we? I don't think so. So I need to revise the syllabus to reflect that we don't have a textbook. All right, I'll make a note to do that, so I can put the topics up instead. All right, now on to the material. I'm going to make some statements here and about Java code and Java programming. And understand that for any statement that I make, maybe you can find an exception. All right? Maybe you can find an exception. So don't come to me the 13th week of class and say, on the first day you said such and such, and here I found this exception. All right? Yeah, there's exceptions, but I'm telling you the basic, straightforward way to do things. First of all, in Java, all your classes, all your code are in classes. All right. And generally speaking, there's one class, there's one file contains one class, and one class is contained in one file. Let's look at the classic Hello World application. I'm going to copy this. I'm going to create a Java class. Now, there's any number of text editors you can use. Use whichever one you are comfortable with. The one I like to use for this and many of my classes is Visual Studio Code. So I'm going to go in and access Visual Studio Code, not Visual Studio, but Visual Studio Code. You got a free download from Microsoft. And I'm going to create a new file. And I'm going to paste that code in. Okay, there's the code. Let me zoom in. Control plus equal. Oh. Okay. All right. So here we are with the Hello World app. I'm going to save it in the file name hello world app dot Java with Java in lowercase. Your file name should match your class name, including case. So in this case, in this instance, hello world, the H, the W, and the A are capitalized. That's standard for class names in Java. According to Java convention, a class name, each word in the class name starts with a capital letter. No other letters should be capitalized. So in this case, I'm going to go and save this. I'm just going to save it on the desktop. And I'm going to call it Hello World app. All this does is it outputs hello world. We have our comments up here. Comments, if they're multiple line, they can start with a slash star and end with a star slash. I then have the fact that this is a class. The curly braces go around the body of the class. I then could have my methods or my functions. Public means it's accessible from outside of this class. Static, we're not going to talk about right this minute. Void means that it doesn't return any value. Main is the name of the method. And string array are the arguments to this. We can actually run this with and give it some arguments. We're not going to worry about that, maybe later on in the class. Now, every Java application that you create needs at least one class that has this main method. And the main method needs to look exactly like this. Public static void main, lowercase, Java is case sensitive. That accepts a string array of arguments. And then the curly braces indicate the body of the main method. Now, in many cases, we're going to do more than simply output hello world. But that's what this particular thing does, is it outputs to the standard output the word hello world. And I know it's going to be the word hello world because that's enclosed in quotation marks. This is not a variable or anything. This is what's called a literal. I'm literally going to output hello world. This is dot notation. We could talk a minute about what this means, and or you can just not worry about it and know this is how you output stuff. This is saying in the system class, there is an output object and there's a print line method within that out object. So the system has a standard output object, and that object contains a print line. If you don't know what any of that means, just always do this, system out print ln, and it will do it to you. All right, we already saved it, and I saved it on the desktop. Let me go and run this. Here it is. Hello world.java. Now, in Java, there's two steps to running the program. The program must be compiled. What compiling does is it takes the code that you've written in the Java programming language and creates what's called bytecode. Let me draw a little diagram here. Let's use our old friend MS Paint. we have our class in Java, something.java. We run that through a compiler, and I'll show you the commands to do that. That produces a .class file. And then that class file can be run by the Java virtual machine to produce whatever kind of output you want. Now, the idea of this is this makes it cross-platform. I should be able to take my .class files, and provided that the other machine also has the correct version of the Java virtual machine run, I should be able to run code that you write on Windows. I could run it on my Mac, or I could run something developed in Linux on a Windows machine. All right. This compiler and Java virtual machine are distinct by platform. The class code, ideally, is not platform specific. It can be as cross-platform. Now, for the beginning of this class, not until the very end, we're not going to use any IDE. We're not going to use anything like Visual Studio or anything like that. I don't want you to do that. Why? Because I want you to sort of understand this from the ground up. I want you to understand sort of the nuts and bolts of everything that has to be done. What does that mean for you? That means you need to install Java. Well, how do you install Java? Setting up your computer to do assignments. Oh, I'll correct that as well. Now, I always proofread these, and I always find some problems. It's pretty easy. I will display. I will put information on doing that. Essentially, look for the Java and you can download. JDK stands for Java Development Kit. Depending on what your machine is, you can pick that. Generally, usually I take the installer. You can download that, and it will take you through an installation process. Should be fairly straightforward. When you do that, you're able to run Java from the command line. Now, I know some of you probably haven't used the command line a lot, but we're going to practice that in this class, and it's not as difficult as you might think. To get to the command line on Windows, you simply run CMD, command prompt. And that will take you to how all computers were when I first learned them. Well, not even that. That's not even true. I actually, all personal computers were. All right, let's put it that way. When I first encountered them. All right, it'll put you by default in your user directory. You want to change directory to whatever folder has your file. And you do that with the CD command, CD desktop. So now I'm in the desktop folder. If it was in a subfolder underneath it, you'd put CD and your folder name or whatever. You can do a dir and see a listing of the files in there. And if you notice, we have hello world app.java. Now, how do you know that you have installed the Java JDK correctly? If you type in Java in the command line, you should get something that looks like this. It's essentially just help. Tells you all the command switches that you can use in doing this. If you get some error that says that it's not found, you either didn't install it correctly or your system path is not correct. And I can give you a hand with either of those questions if you have that difficulty. So I'm going to compile it, and you first compile it by typing in Java and the name of the class that you're compiling. That's what I wanted. Every time there's new windows, I have to figure out where they put things. I just want to make the text bigger. There we go. All right, there we go. So I type in Java and Hello World app. And I hit return. My mistake. It's been a long summer. Type in Java C. Hello World app. And it didn't display anything. That's good. That means it didn't find any errors. Once I have compiled it, then I can run it by typing in Java and the name of the class. This needs to be the class that contains the main method. And there I go and run it and say hello world. If we look, it created that hello world class. That is the bytecode. That is what you could take and give to another machine. And provided they had the correct version of the Java runtime engine, they would be able to run this code. So the first thing you should do is try to install Java and try to create this application, take the code from the example on Canvas, create this application and run it and make sure you get the correct results. Make sure that you have installed Java correctly. I would do that as soon as possible because, you know, if you don't get that right, you can't make any progress in the class. So do that as quickly as possible. Ideally within the next couple of days. If you do use machines on campus, Java has already been installed, so you don't have to worry about that. Okay. we're going to look at now sort of an enhanced version of the Hello World app. So I'm going to download it. And it is in a file called hello world_1.java. I'm going to make a new folder, call it lab 1. So I'm going to go and I'm going to open this with Visual Studio Code. And it's similar to what we had before, but it's a little bit enhanced. Now, you might notice something right off the bat. The file is called hello world-1.java, and the class is named hello world. That isn't going to fly. So we'd have to make sure our class name matches the file name. So I'll go and rename this. Want to do that. I'm going to just rename it to hello world.java because that's the name of the class. Then when I open that up in Visual Studio Code, the file name is hello world. Class name is hello world. That matches that, and the case matches as well. And also, the first letter of each word in hello world is capitalized. All right? That needs to be, you need to follow this convention. We'll talk about more conventions as this course goes on. In fact, let's talk about it in this example. This is a little souped up example where I have an array, that's what this means, string array, named names that consist of these 4 elements: Mike, Joe, Jerry, and Joyce. I have this function where I call the math random function and multiply it by 4. The math random function gives me a number between 0 and 0.999. If I multiply that by 4, I'll get a number between 0 and 3.999. And if I truncate all the decimal points, which this does, I'll end up with a number from 0 to 3. And just like in C#, I can then say names sub random, and that'll put in the value of that random number that I generated. So I'll give a number 0, 1, 2, or 3, and it will display the proper name. Now notice a few things. Function names are lowercase. The first word is lowercase. If there were more names, more words in the function, each subsequent word would be capitalized. So if it was main function, it looked like that. But it's not. String is capitalized. String is a class name. All right. A class is a type that a variable can be. Args is the name of the variable. In this case, it's the argument of the function, and it's lowercase. Notice we have the same thing here. Names is lowercase because it's the name of a variable. String is uppercase because it's the name of a class. Now you might say in int random, why is int lowercase? It's lowercase because int is not an object. It's not a class. Int is what's called a primitive. And there's a handful of primitives in Java. let's Google Java primitives and it will show us what they are. There's 8 types of primitives. Boolean, byte, short, int, long, float, double, and char. Now we'll talk more about the difference of what the difference between a integer or an int and a string. In other words, the difference between a primitive and an object or class later on in this course. So, public class hello world. This has the name of the main function in it. This declares an array. This generates a number between 0 and 3, and then it outputs the word hello and concatenates whatever number we generated, that name, from the array list. Make sure it's saved. Go to my command line. Hello world.star will give me, oh, I put it in a separate directory. So I'm in the desktop, I need to go to lab 1 directory. Now I can do a directory listing and it'll show me that file name. I could also do dir hello world.star who world. And it'll give me everything that starts with hello world. Or I could do well, yeah, I do hello dir h. Gives me everything that starts with H. So now I'm going to compile this, and you compile with Java C. No errors. That's good. I can use my up and down arrows to go flip through the commands I previously entered. So I can go up and do a dir h again, h star. And I can see there's now a hello world.class file. That's the bytecode that I told you about. And that's what we're actually going to execute. And it will tell me the name. I could run it again. And it generates a name randomly. Now, if you remember the first time here, I typed in Java and typed the name of the Java source file. Don't do that. That sort of compiles and runs it all in one step. It's best to do the compilation and then run it separately. Okay, so what do you need to do for your first lab assignment? All right, first thing you need to do is you make sure that you have Java installed. And I will post a change to this to post a resource about installing JDK. I'll see if I already have that, but for your first lab assignment, it'll be in the module 1, week 1. Create a Mad Lib. So for example, if you had the nursery rhyme, Mary had a little lamb, remove Mary, lamb, and fleece and substitute random words for a list you came up with. Abby had a large rabbit. Create a similar program. Make sure you substitute at least 3 worlds and have several options for each world. That's very similar to what I did, except it's taken to an extra degree. Where I just had 1 array of random names that got pulled, you'll have 3 random arrays. And you should have 3 random numbers to pull out a random element from each thing and from each of the arrays. And then you'll output the hard-coded part of the poem or Mad Lib, and then you'll add the value from the variable. All right, are there any questions? All right, well, that's all I had today. Remember, next week is Labor Day. I will post a lecture from a previous semester so we don't fall behind. We'll see you live the week after next. Please do not hesitate to ask if there are questions.